All right, so in this lesson, we're going to learn how to use the law of cosines. So why do we need to learn law of sines and law of cosines? Well, the law of cosines is used when we're given side, angle, side, or side, side, side. So that would be like side, side, side would be like if we were given all three sides in a triangle, right? How do we find the angles? Well, it's side, side, side. So that would be law of cosines. Now, it should make sense that it's not the law of sines, because if you tried to do the law of sines, you would have two variables, which means you don't have information to solve. So if I was trying to find the sine of A, I could do the sine of A over 8 equals the sine of C over 7. All right, that we can't solve because we have two variables. So if you find that you're using a law of sines and you have two variables, you probably should be using a law of cosines. All right, and the same thing would happen if sorry, someone just entered. I gotta let him in. Same thing would happen if we did side, angle, side. So let's say you're given that this angle was like 70 degrees, and this was like 10, and this was like 11. All right, no matter if you're trying to find any side or angle, if you use the law of sines, if you tried to set up an equation, you'd have too many variables. Like if you did the sine of 70 over A, then you would set that equal to like the sine of B over 11 or the sine of C over 10. No matter which two of those three you set equal, you would have two variables. So again, if you forget and you're doing the law of sines and you forget that side, angle, side, or side, side, side doesn't work for the law of sines, you'll naturally run into an issue where you'll get an equation that you can't solve. All right. So law of sines, though, works well with side, 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 or side, angle, side, because if we look at these formulas here, all right, the uppercase and the lowercase is important. So the uppercase is going to be the angle. So if we had a triangle here and I made this angle A, all right, I would make it with an uppercase A. Now side A is directly across from it. So whatever angle that this represents that you plug into the cosine part, all right, this side A, lowercase a, should be the side across from it. All right, and then B and C are across from angles B and angles C, and they're actually pretty interchangeable because you notice you just take them and you square them and then subtract 2 times B and C. So B and C are going to be across from the angles that you're either not looking for or you're not given. And then those could be interchangeable either way. And depending on what you're solving for, you can write this formula like 3 different ways. Now, keep in mind that if you put angle B here, all right, now side B has to go here. And then sides A and C could be the other 2 sides. And if you were to plug in angle C, if you did the cosine of C in this law of cosines, then whatever side you put here must represent the side across from angle C. And then now A and B are the other 2 sides, okay? So when given side, angle, side, we're gonna use the law of cosines to solve for the unknown length. So the side across from the angle that we're given, and then use the law of sines to solve for the smaller angle first. Now that's really important, and I could get into it later, but I'll describe a little bit of it now. If you ever do the law of cosines and you want to use the law of sines after it, you must do it on the smaller angle. And pretty much the reason why has to do with the ambiguous case. If you did it to the larger angle, the law of sines, if you use the law of sines to find the larger angle, and that angle was obtuse, then the law of sines would actually tell you the wrong angle. It would tell you the acute angle, because we know that side inverse only gives angles between 90 and negative 90. So you'll never get an obtuse angle when you do the law of sines. Now, if you do the smaller angle first, there's no chance it could be an obtuse angle because there's only room for one obtuse angle in every triangle. So just keep that in mind. Whenever you're doing the law of cosines to find that first side or angle, you'll never have any issues. But for that second angle, All right, if you want to do the law of sines, find the smallest angle first. And I'll go over that for a specific example. All right, another option that's not listed here is to do the law of cosines twice, because cosine inverse is equal to angles in quadrants 1 and 2, which means cosine inverse could equal an obtuse angle. Cosine inverse could equal anything between 0 and 180. So you could also avoid this smaller angle stuff by just doing the law of cosines twice. All right, so in conclusion, all right, when you're doing the law of cosines, after you do it the first time, the second time, do the law of sines to find the smaller angle. Or if for whatever reason you don't want to do that, you could also just do the law of cosines twice. Either thing works. All right, and I'll show you an example later on. Let's get into it. So solve the triangles, draw a picture for each. All right, so let's draw this picture. So do this along with me. So I'm just going to make a triangle. I'm going to make it look equilateral, even though it's not. I'll make this A, make this B, and this C. All right, so this angle A would be 42.5 degrees. Okay, this angle B would be 71.4. All right, and then side A would be 215. Now, if you read up on the top, I can't scroll up or else I'll lose the picture here, but it says use a law of sines for, use a law of cosines for side angle side or side side side. Now this is angle angle side. So this would be a time where we use the law of sines. So we don't need to use the law of cosines here. So to do the law of sines, we need to do that to find the other two missing sides. So if I were to first find this missing angle here, I could subtract, so angle C, I could get by doing 180 minus 42.5 and then minus 71.4. All right, I'll type that in my handheld calculator. I'm sure I'll pull up the actual calculator later, lol. So we got 66.1 degrees. All right, so it says solve the triangles. All right, we're almost there. We got all three angles and one on the sides. Now we got to find the two other sides. Okay, now we are going to use the law of sines because again, we have enough information to do the law of sines. And you know that because it's angle side that we were given. So if I do control division here, I could do the sine of 42.5. All right, make sure the calculator's in degrees, and it is, over 215 is equal to, now if we want to find angle C, or side C, sorry, we would do the sine of 66.1 because that is the angle across from C. All right. So again, this probably seems like review because we're doing law of sines, and it is, but it's important to know when you don't need to use the law of cosines just as much as knowing how to use it. And this would be a case where we don't need the law of cosines. So we're doing the law of sines. So now to solve that, I'm going to cross multiply. So I would put the C on this side and then the 215 on this side. So cross multiply. All right. And then now I could divide both sides by the sine of 42.5. And I get C. And we get 290, which makes sense because the side across from 42.5 is 215. So the side across from a bigger angle than that should be a little bigger. So I'm actually going to round that up to 291 because it's 290.95. So I can actually do 291.0 to show that I rounded to one decimal place and I rounded up. All right. And then do the same thing to solve for side B here. Okay. So again, do the law of sines. So that would be the sine of 42.5 over 215 is equal to the sine of 71.4 divided by b. All right, then I could cross multiply, and I would get b times 42.5 equals the sine of 71.4 times 215. All right, and then divide both sides by the sine of 42.5. All right, so I'm just doing algebra there. It'd be easier to see if I was writing that on a whiteboard, but it's tough to do with this. So we solved that equation and we got 301.6. And then we just solved the triangle and then we're done. And we didn't have to use the law of cosines because we were given angle, angle, side. Okay, now let's look at the next example where we're given side A, side B, and angle C. So that would be side, angle, side, because angle C is going to be in between sides A and B. And to see that, we'll draw a picture. So I'm going to try to draw this somewhat to scale. You don't have to. You can always do the equilateral triangle thing like I did last time, but it says that, oops, I misread that. I thought it was 120 degrees, so let me try that again. All right, so 60 degrees. By drawing it to scale, I just mean like if it's an obtuse angle, I'm going to make it look obtuse. All right, so that would be angle C. All right, and then this would be side C. Now, if we call this angle B and this angle A, the side across from angle A would be side A. So it's 120 inches. And then the side across from angle B would be 66 inches. Okay, now, the law of cosines is C squared is equal to A squared plus B squared. Now, if I stop right there, that should look familiar. All right, that's the Pythagorean theorem. And the law of cosines is very closely related to the Pythagorean theorem. It's just what you do for non-right triangles. So it has part of the Pythagorean theorem in it. And then you also have the times 2, times A, times B, times the cosine of C. Right? You don't have to memorize that because, you know, we're taking these classes virtually. So you can always just write that in your notes. But even if we weren't, all right, you could just know how to use the law of cosines. But if you use it enough, you should have it memorized. You'll memorize it eventually. All right, so for C, side C goes here. I don't know what that is, so I'm going to keep that as side C. All right, side A is 120, so I'm going to square that. Plus, remember that little caret 2 means squared. Plus side B squared, which would be 66 squared. All right, minus 2 times A, which was 120, times B, which was 66, times the cosine of C. And I should write 60 there because, again, I know that 60 degrees is across from the side that I'm looking for. And if it said, like, find angle A or angle B, right, now we're solving for all parts of the triangle. But my point is, if we had to only find angle A or angle B, we still have to find side C first. Right? So if you're given this situation, right, side, angle, side, then you can only do the law of cosines to find the side across from the angle first, in this case, side C. Then you can use that to find either other angle. All right, so so now I'm going to solve this. So I could just type all this into my calculator, exactly how it looks, and then take the square root. So that's what I'm going to do. So I get 120 squared plus 66 squared minus 2 times 120 times 66 times the cosine of 60. All right, and again, if I'm going too fast, if you have questions, just stop me. And if you're watching this recording, then just pause the video if I'm going too fast. Or fast forward if I'm going too slow. All right, so type that in the calculator, boom. Now that would be C squared. So if you ever get a side that's like really big, all right, you probably just forgot to square root it. All right, so now we have C squared is equal to that number. Oops. So C squared is equal to, oh, lost it. 10,836. So 10,836, which I believe is the current price of GameStop right now. 10,386. Did I write that down wrong? No, I'm dyslexic. 836. Oh my gosh. I shouldn't even wrote it. You guys knew what I was doing. Oh my goodness. These things take way longer than you think. Oh, all right, sorry. 836. I would hate this part of class if I was you guys. It's probably like watching paint dry. I apologize. Doing the best I can. All right, now take the square root and we get side C. So type that right in the calculator. All right. Oops, lower this a little bit. Yeah. So do the square root of that number, because again, this is what C squared is. And we get, now the calculator, I have a TI inspired cast, so it's gonna simplify that radical for me, which is a very nice thing to do. But when we're finding sides of non-right triangles, we could just round it as a decimal. All right, and we get, now to do that on a TI inspired cast, you're going to highlight this, so arrow up, hit enter to copy and paste it, and then control enter will approximate it as a decimal. All right, and we get 104.096. We'll round to 104.1. All right, so this side right here is 104.1 inches. Okay, which kind of makes sense because 60 is like a pretty big angle. You know, it's in between these two side lengths. So angle A is going to be bigger than angle C, and angle B is going to be less than angle A and C. All right, which makes angle B the smallest. All right, so now if we're going to do the law of sines, we have to do it for angle B, because angle A is definitely the biggest side because it's across, sorry, angle A is the biggest angle, and that's because it's across from the biggest side. So that means that angle A could be obtuse. And if we did the law of sines wouldn't tell us it's obtuse if it was. It would tell us it's the supplement of that angle. All right, because let's hypothetically say that we did the law of sines with angle A. So we did the sine of A over 120 is equal to the sine of 60 over 104.1. So this is why. So this is the wrong way to do it. But I'm explaining right now why when you do the law of sines, after doing the law of cosines, you should do it to find the smallest angle. The reason why is because when we set it up like this, we're using angle A, which we don't know, and we're using 120, we're using 104, and we're using 60. So we are completely ignoring that this side is 66. All right, so we're not using 66 in this equation here. Now, if you look at that, that's ASS. That's the ambiguous case. And we know that with the ambiguous case, there could be two triangles. So if we were to like find, I'm not gonna actually, so if there were two triangles, so like if you found this height, all right, and found that there could be two triangles, well, angle A could look like this, or it could look like this, where like angle A could actually be over here, which would make this angle obtuse. But if you do the law of sines, it's only going to tell us it's the acute version of the triangle, because again, when you ultimately find A, you're going to have to do the sine inverse of something and like blah, blah, blah. And that's only going to be between 90 and negative 90. So it wouldn't tell you if it's obtuse. All right, so that's why you should always do the law of sines on the smaller of the two angles. Now, sometimes you get lucky and it'll work itself out, but you will sometimes run into issues if you do the law of sines after the law of cosines and it's not on the smallest possible angle. All right, so now I'm going to erase everything here, but this part's good. The sine of 60 over 104, that part's fine. But now instead, I'm just going to find angle B first. So we get the sine of B over 66. Okay, so now I got to cross multiply. So that times that equals that times that. All right, so I'm going to do that on my calculator. So if I do 66 times the sine of 60, I get 33 root 3, which as a decimal is 57.15. Now that's going to equal the sine of b times 104.1. So I'm going to divide both sides by 104.1, and I get 0.5490. So that's what the sine of b is equal to. That. So to solve this equation, I'm going to do the sine inverse of that ratio, just like we do when we do law of sines, and we get that that angle is 33.3. Oops, I paused the share. All right, so this angle is 33.3, which means that angle B actually wasn't obtuse anyway. All right, it ended up being a large acute angle. All right, but now we could find it without doing any law of sines or law of cosines. We can just do 180 minus 60 minus 33.3. All right, so you get the angle B is 86.7 degrees. Now, if angle B was obtuse and we did the law of sines to find it first, we would never have found it correctly. All right, so long story short, if you do the law of cosines, then to find the next angle, do the law of sines on the smaller of the two angles. And you can tell which one's smaller by seeing what sides are across from each other. And I realized I just made a mistake here. I wrote these in the wrong spot. So that's silly me. This should be angle B. So angle, oops, I lost that whole side. So let me write that correctly. Oh. All right, so this is this side, whatever. Angle B came out to be 33.3. I noticed it because it was across, it should be across from the smaller side. And this would be 86.7. So I did everything correctly, I just wrote it in the wrong spot. All right, so now that's what the triangle looks like, and now we have it solved. All right. Any questions, let me know. But let's finish the last two, and maybe we'll skip this next one because this is one where it's angle, side, angle. So we could just do the law of sines. So I'll just set it up for you, and then I'll let you guys solve this on your own, or you could just not solve it, it's fine. So how do I know that this doesn't require the law of cosines? Well, when I draw the triangle, oops, let's try to make this an acute angle here. Okay, so this will make this angle A. All right, that's going to be 105 degrees. Angle B, doesn't matter which one we make it, we'll make this angle B. And then side C is across from angle C, so this should be angle C. This is going to be 630 degrees. All right, so for this one, if we had to solve the triangle, all right, you don't need to do the law of cosines because we're given angle, side, angle. So when you're given two angles, you could find the third angle by subtracting the two given angles from 180. So that's nice and easy. Oops, I got a chat here. Let's see what someone said. So if I do 180 minus 45 minus 105, I get this angle here is 30. All right, and then now you could just do law of sines to find the other two sides. So you could say, like the sine of 30 divided by 630 is equal to the sine of 105 over side A. So you could solve that. All right, and then you could set the sine of 30 over 630 equal to the sine of 45 over the side across from it. All right, and then that's how you find those two. So I won't waste your time because I'll assume you know how to do that. But if you want me to go over that later, just let me know. Nope, someone's not happy. Does it matter which sides label A, B, and C? Good question. So yes and no. Like in this case, they tell us which angles are A, B, and C, but you can always change it as kind of. So no, it doesn't matter. But like once you assign certain angles or sides, certain letter names, you should like stick to it. So so what I said at the beginning was like, let's say you're given a situation where like this is F. We'll go for the Super Bowl. So this is triangle NFL. All right, and you were given like this angle was like 27 degrees, and this side was like 10, and this side was 15. All right, and you have to find like side F. Okay. Now, how do you know which one of these formulas to use? It doesn't matter. The thing that does matter is that whatever angle you plug in here, that should be the side across from it. And whatever you plug an angle here, that should be the side across from it. Whatever angle you plug in there, that should be the side across from it. So if I was trying to find angle F, all right, and I was using, say, this formula here, all right, well, I would make this now, angle A in the formula. And then this would be side A because it's across from it. And then B and C don't actually matter as long as you get the correct pair for angle A and side A. So then this could be like side B in the formula, and this could be side C. Or you could switch them around because they do the same thing in the formula. You just square them and add them, and then you multiply them here. And you could do that in any order. All right. Now, last but not least, and then I'll end this video here. How do you find a missing angle using the law of cosines? All right, so first, let's draw our picture. All right, so we have a triangle ABC. All right. This would be angle A. This angle B. Oh, my angle C. All right, so the side across from angle A will be side A. So this side here would be 22 yards. All right, the side across from angle B would be side B. So this would be 24 yards. And the side across from angle C, 26 yards. All right, so it doesn't matter which angle we find first because we're going to use the law of cosines. Now, it's best to find the biggest angle first because then you definitely won't run into issues with an obtuse angle in the second part when you do the law of sines. All right, so in other words, like this angle A or this angle C here is the only one that could be obtuse. All right, and we only run into issues with obtuse angles when we use the law of sines, and we have to use the law of cosines here because we don't have enough information for the law of sines right now. So it's probably a good idea to find the biggest angle first whenever possible. All right, so we're going to set this up now. So I'm going to let 26 be side C. All right, so that's going to equal side A plus side B minus 2 times side A times side B times the cosine of angle C. Now again, the only thing that matters in this formula is that if whatever side I put here, in this case 26 yards, all right, then whatever angle I'm solving for here represents the angle across from that side. All right, so now we have to solve for the cosine of C. So to do that, we're going to get the cosine of C alone by first subtracting 24 squared and 26 squared on both sides. So now it's like we're just solving for a variable. We're solving for C. So I'm going to subtract 24 squared and 22 squared on both sides. All right, so that's my first step to getting C alone, okay? Subtracting a squared and b squared on both sides. Okay, now I want to get the cosine of C alone. So what I'm going to do is I'm going to divide by anything in front of it that's being multiplied by it. Oops, I meant to make this a different color. All right, so I'm going to divide both sides by -2 times 24 times 22. All right, do that on both sides. -2 times 24 times 22. Now remember, when you're solving for a variable, SAD-MEP is PEMDAS in reverse. All right, that's how you remember the order of what you're doing. So like SAD, SA, you know, first we're going to add and subtract on both sides. That's why, like from here to here, we subtract the 24 squared and 22 squared first. Then we multiply and divide on both sides. So that's why here we divided both sides by -2 times 24 times negative times 22. All right, we divided by -2 times 24 times 22. So now we're left with the cosine of C, all right, is equal to this number right here, which should come out to a nice ratio, like a decimal between 1 or -1. So let's figure it out. Let's type that in our calculator and see what it equals. So now in the calculator, kind of don't have enough room here, but we're doing our best. Yeah, right there is good. Well, then you can't see that. All right, whatever. So I'm going to type that in. I'm going to go control division. I'm going to type in 26 squared minus 24 squared minus 22 squared. All right, divided by -2 times 24 times 22. And we get a nice 4/11, which usually will come out to like an ugly decimal, but that, you know, 4/11 is a nice rational expression there, simplified nicely. So it comes out to be 0.3636. So now we have the cosine of C is equal to 0.3636. All right, so now we could just do the cosine inverse of that number to figure out what C is. All right, so cosine inverse, so do trig cosine inverse of that ratio. And we get 68.67 degrees. So we'll round that up to 68.7. All right, so now we know that this angle here is 68.7. And now we got to do the law of sines. And I don't like that 6. I got to fix that. 68.7 degrees. Okay, so now we got to do the law of sines to find the third angle, or the second angle. And then we could just subtract the other two from 180 to find the third angle. All right, now, according to the rule at the top of the page, we should find angle A first. But it actually doesn't matter because we already found the largest angle. But it's just good habit to just always find the smallest angle first when you're doing the law of sines. So we're going to do law of sines now. So we're going to do the sine of A over the side across from A equals sine of 68.7 over the side across from that. All right, so cross multiply. So multiply like 24 on this side, and then multiply like 22 on this side. All right, and then divide both sides by 24. The sine of A is equal to 0.85405. So now we could solve for A by doing the sine inverse of that ratio. And we get 58.65 degrees. So we'll round that up to 58.7 degrees. Oops. Oh my goodness, and I did this same stupid thing before. All right, I did everything right, but then I wrote this in the wrong spot. Oh man, I didn't even do that. Oh, no. All right, it's angle C, which we got to be 68.7 degrees. So that's my fault. Too many things going on. I made a silly mistake. But none of the work, nothing I said or did was wrong, other than I just wrote that in the wrong spot in the picture, which is wrong. So, all right, cool. So now, now we finish up by finding that third angle by doing 180 minus 68.7 minus 58.7, and we get 52.6. Right, and that would be the measure of this angle here, 52.6 degrees. And there you go. That's how you solve a triangle. All right. So in conclusion, just to summarize everything, all right, when you're given side, 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 or side angle side, use the law of cosines to find missing sides and angles, that first one. And then after that, once you find that missing side or angle using the law of cosines, you can then use the law of sines to finish solving the triangle. Just make sure for any angles that you're solving, you find the smaller ones first, and you'll never run into any issues. All right. So if you have any questions, let me know. If you don't, you are free to go and the homework, which is just these 4 problems here. All right. Wow, you gotta love when you say you're free to go and someone immediately bounces, but you know, I guess I said you could leave, so that's fine. All right, so thank you. All right, stay on if you have questions. I'm gonna end the recording. But if you don't, have a great day. Get that to me, and if you're missing